Afternoon, everybody. Another splendid day here in the shop. I want to make a quick video, hopefully a quick video, on the parts that I have purchased for the for the PrintNC CNC. First of all, let me start by saying I did not use the AliExpress store that Mark has worked with through his 3design.store website. I would probably highly recommend that. I saw a couple of deals for a few parts that I could get on Amazon or eBay that were a little better than what they had on the AliExpress store, so I said, hey, I can do this myself. At the end of the day, I don't think I could do it better myself. I think that you'd be better off going with the AliExpress store. If you do it like I do it, you're probably the kind of person who tries to mount their own tires to save the $10 from the tire store. You do that one time and you realize it's money well spent. So I will go over my parts and kind of tell you what my thought process was on this and why I did what I did. You do what you got to do. So the first thing that I purchased or found online, which really drove everything else with my build, were these ball screws. These ball screws are 1605 ball screws. I have 3 of them. 1605 is the part number for a ball screw, 16 millimeter is the diameter, and 5 millimeter is the pitch. So with every rotation of this ball screw, this ball nut moves forward or back 5 millimeters. Most folks that are building a machine this big will use a 10 millimeter pitch ball screw. I am probably going to wish that I did as well. I am not looking for production speeds out of this machine, but I don't want something so slow that it's aggravating to use. So I'm going to go ahead and build with the 1605 ball screws because, one, I've already purchased them and might as well see what it will do. There's also a concern with a 16 millimeter screw of screw whip. In other words, when you get this spinning fast enough to move the gantry at a reasonable rate, it will induce some vibration into this. I don't know if that's going to be a problem yet or not. You may want to watch my build before you jump in and say, oh, well, Jeff got 5 millimeter pitch ball screws and they work fine. Let me finish building mine and then we'll see. So along with the ball screw, I do have BK12, and somewhere in here is a BF12 ball screw bearing, and those are just the bearings that go on to hold that. The BF12 goes on the driven end. The BK12 goes on the driven end. The BF12 goes on the floating end. So those go on. Those will eventually mount here on the rails with the use of some 3D printed spacer blocks. So the next thing that I ordered were, let me step back up just a little bit. These ball screws, and the reason why I went with these were $51 on Amazon for the screw and the nut, and I think maybe a coupling, but definitely not the bearings. Had to order those separate. I ordered these, I got them in, and I said, okay, I've got 1,550 millimeter ball screws. I got them at a killer price. How big of a machine can I build? So I went in and I used the frame size calculator on the 3design.store website, and I came up with 65 inches by 65 inches. So that's how cheap ball screws probably led me astray in all this. So the first issue I found was when I came to buy my linear rails. If you know from the design of the PrintNC, your linear rails should be 100 millimeters shorter than your ball screws. Problem with that is no one makes or no one has easily available 1450 millimeter linear rails. So this is a 1500 millimeter linear rail. Whenever I get to putting the linear rails on the machine, I'll explain to you how I go about dealing with that extra 50 millimeters of length. I do have the option of cutting this. I could cut it 50 millimeters short, which is roughly 2 inches. I have a horizontal bandsaw that will cut this no problem. But if I have to upgrade to a 10 millimeter pitch ball screw, I'm going to go with 2010 ball screws, and the length will be 1600 millimeters. So I want to keep that extra 50 millimeters just in case I do need to upgrade my ball screws. So these came in a set of 2 linear rails and I think 4 bearing blocks, and they were $100. So I ordered 2 sets of those, 4 total, 2 for the Y, 2 for the X, from Amazon. One of the things that I immediately noticed whenever I started building my roller is that the kit that I bought from Amazon came with the narrow blocks. So here you can see the 2 blocks. I have this is a regular block or a narrow block, and then this is the wide. I think I could have got by with these, but I went ahead and ordered some of the wide blocks off of eBay because they work with all of your drill guides. So Mark did a good job of making all of the drill guides. I said, well, I'll just go ahead and order some of the wide blocks. So I have wide blocks and narrow blocks. So that's one spot where I cost myself probably $50-$60 for the blocks. So that is the linear motion for the X and the Y. For the Z linear motion, I do have a ball screw. This is a 12-4 ball screw. With my build, I have an extended X gantry, which is 4 inches versus the 3 inches. So my Z plates and my Z drive is going to be at least an inch taller. Also, I want the spindle to be able to go all the way actually below the wasteboard. So I'm gonna modify the Z plate a little bit more. I'm not sure exactly how I'm going to do that, but I did know that with my indecisiveness, I didn't know how long of Z linear rails to order. So what I did is I ordered a 1 meter linear rail with the 2 guide blocks, and I think that was $50 on, I think that one also came from Amazon. So as soon as I figure out how tall I'm going to make my Z-axis, I will use my horizontal bandsaw and I will cut these linear rails to the correct size. So I'll make 2, both of my Z linear rails will come out of this stock right here. So that's all of the linear motion parts. For movement, I did purchase 4 of the NEMA 23 stepper motors. Those came from Stepper Online. I paid $29 plus shipping for these. These motors are a little bit different than what the normal PrintNC is in that these are 8-wire stepper motors. This is a 400 ounce-inch 2.83 Newton meter stepper motor, which you'll notice is a little bit less than the standard 425 ounce-inch that you can get on AliExpress. I went with the 8-wire over the 4-wire for a very specific reason. And with having to drive this ball screw faster, with an 8-wire, you can significantly reduce your internal impedance on your stepper motors. the reason with these are 8-wire, and these can be wired either in parallel where they act just like a similar sized 4-wire motor, or you can wire them in parallel, which is where you get the reduced internal impedance. That comes at a cost, though. You can drive it faster. However, you get much less torque out of it. Now, I'm betting right now that torque is not going to be an issue on this build, simply because I have 2 stepper motors to move the X gantry in the Y direction, and I'm using 1605 ball screws, which with your ball screw, the shorter your pitch, the less torque you're going to need. So I'm banking that I can drive these fast enough to be usable with the 1605. Time will tell on that. One of the differences that you'll notice is I do have these stepper motors mounted on a steel bracket. I got these brackets from Amazon. It was $10 for 4 of them. The reason why is I'm planning on having to drive the heck out of these stepper motors. They will get hot. I don't want the heat to build up and be a concern with the 3D printed motor mounts. The 3D printed, that's a thermoplastic, and anytime you get it hot, it can deform. I didn't want to have to deal with that, so what I did is I made some new motor mounts that are considerably shorter, and will bring the motor mounts just about the same, only it uses the steel bracket. So in order to drive the stepper motors, you will need a stepper motor driver. I have the micro step driver DM556. I bought these. Will do 5.56 maximum amperage. These are 4 amp stepper motors, so these should be plenty. These have up to 50 or 60 volts for the maximum voltage, and I'm going to be running 42 volts. Again, the stepper motor driver takes the pulses or the input from your computer and then steps that up to drive your stepper motors. So that your drivers can talk to your computer, you will need some sort of breakout board. I have here a parallel board. I will probably use this in conjunction with Linux CNC. I may stay with the Gerbil or Gerbil or Garble or GRBL or whatever you call it with the Arduino, just because I'm already used to that. I already have the universal G-code sender. And I may not want to twist too many knobs at once. I may just bring that system over here, at least to test out all of my motion for my machine. I realize that the Garble, Gerbil is not as functional as the other options, such as Mach 3, Mach 4, Linux CNC, and a few others, but it should work. So to power my stepper motors, I did do a couple of different calculators online. They all showed somewhere between 45 and 50 volts would be needed. So I opted to go for a 42 volt power supply, and this is a Cisco, this is a used or surplus computer server rack power supply. These are very common on eBay. I've got this one off of Amazon. These will do 42 volts, 12 volts, 5 volts, and 3.3 volts in varying amperages. This happens to be a 2500 watt max power supply. I had looked into doing 48 volt power supplies from Amazon, eBay, AliExpress. Most of those are 300 to 600 watts. I would have needed to buy 2 or more of those to make it work with my 4 amp stepper motors. That pencils out to be somewhere around 700 watts. You want to give yourself a little room to breathe. So I went with this. This was cheap. This was $18. It actually cost me more to ship it than it cost to buy it. It was $18 and I think $25 to ship it. The only difference, but this is the, as I said earlier, the 2500 watt model. The only difference between the 1300 watt and the 2500 watt is this can be powered with 240. The 1300 watt is only 120. If I were to power this with 240, which I'm not going to, it would allow me to get almost 56 amps on the 42 volt line. Running it off of 120, I can still get 27.5 amps on 42 volt line, which is plenty. I'm only going to use 16 amps. This does have a proprietary-ish connector on the back. What I will do is I will actually go in to the back, disconnect that connector, and I'm just going to run a 42 volt, a 5 volt, and a 12 volt line out. Run those to some sort of terminal board. Now, I let myself I got in front of myself once again on this. I ordered it. I said, oh, I'm going to need a power cord. I ordered a power cord, which is a standard 3-slot power cord. Then once it arrived, I realized, oh goodness, that's not the right one. So I went back to Amazon and said, hey, I needed the actual slot. And the difference, I don't know if you can tell the difference on these or not. I don't know if it'll show up on camera. On the 110, 1300 watt, the slots, the tabs run this way. On the 240 volt, they run this way. So there's that. I went ahead and asked for a return and a refund on this one from Amazon. They refunded my $6 and told me to keep it, not to ship it back. I guess it would have probably cost them more to ship it back than it was worth. So I got an extra. If you've got a 1300 watt Cisco power supply and you need one of those and you want to pay the shipping from me versus the shipping from Amazon, give me a message. I'll give you that one. Not sure what the shipping will be. Probably about what you can buy one for online. So the next thing that I got ahead of myself on was the spindle. This is a Makita palm router. This is a 700 series palm router. I bought this. I did buy a reconditioned one from CPO Outlets. It has all of the base and guides and all over here in a box. 65 millimeter mount. This is going to be my spindle for starters. I was perfectly content with this. I've been using a CNC with a palm router for a spindle for over a year now. It's done everything I needed it to do. Then this past week, Mark has been posting a bunch of videos of him using his spindle and his PrintNC. He's cutting mild steel, stainless steel. I think he was cutting diamonds the other day with one. So I now have spindle envy, and I'm going to go ahead and upgrade to the 2.2 kilowatt VFD 3-phase spindle. But I'm going to probably start the machine with this. That's really no loss because in my wood shop I can always use another palm router. If you've ever done a big project where you needed multiple router bits for a project, you know it's a pain to switch back and forth. I think I gave $60 for this, so with shipping it was under $65. So that's good. So now I have a spare palm router whenever I need it. The mount will mount a 1.5 kW spindle, but not the 2.2. The 2.2 is actually a 100 millimeter spindle. So about the only thing we got left to talk about is our cable chain and our hardware. Cable chain can get, oh my goodness, expensive depending upon, I'm not sure what it depends on. I guess some manufacturers are just more proud of theirs than others. These came in 1 meter blocks. So These links will break apart, and you can add or subtract links as needed. What this does, if you're not familiar with cable chain, is you connect one end to each one of your moving parts, and as it moves back and forth, it keeps all your cables contained so they don't get tangled up, tied up, or into your spindle. So I bought 3 meters of this, and hopefully that'll be enough for my build. This was cheap. This was $7 for a meter long stick. I think I got that on eBay. So the last thing that I need to talk about is the hardware. And hardware is going to be kind of particular for those of us here in the U.S. Everything on the PrintNC is spec'd out in metric, which is fine, because imperial socket head screws are no more or less common than the metrics here in the U.S. But generally, if you go into a hardware store here in the U.S. and you go to buy metric fasteners, you're going to get them in a 2-pack like this. And that 2-pack is going to cost you anywhere from $1 to $2 a piece. These are M6 by 20 millimeter socket head screws. I bought a pack of 100 of them from Grainger for, I think, $3.50 or $4. So I did go to Grainger.com, and I got most of my connectors, and they're all this Fabry brand. I'm not familiar with it. I'm sure that they're made in, these are actually made in Vietnam. So made overseas. I'm sure no one's making metric fasteners in the U.S. right now, and if they do, then you're going to pay a pretty penny for them. But the Fabry, all of these 100-pack bags were $3 to $6 depending upon what it was. So I got multiple bags. I got a few more down here in the floor of varying lengths of M5 and M6 bolts, and I think that's all they are. One caveat with that, I did start out as suggested with these button head M6 bolts, and that's what I started using for putting my frame together. Very first one I put in, I stripped out the head on and had to drill it out and made myself mad. So I went down to our local Fastenal and I bought some full head M6 by 14 for bolting my frame together. And those work fine. There are a few places where you need these, and I think it's because there's some space limitations on a couple of these connections. So far, I've been able to get by just fine with the M6 full head. These were a box of 50 it was $9 at the local Fastenal. We don't have a Grainger here local to me, so I did have to go to Fastenal. I think Grainger for this stuff had a little bit better price. Well, I know they had a better price. Probably could have ordered these, but again, impatient, so I wanted them now. They had them here. They said, hey, your stuff's ready. I went down to pick it up, and they were like, oh, all we have is your washers. The bolts won't be here till tomorrow. So I had to wait anyway. This is an M-thread, 1 meter, all thread. I got it off of Grainger when I got the rest of my bolts. It was dirt cheap. I think it was $1 a piece. I think I ordered 5 pieces of it. I won't need that much for this project, and what those are going to be for is to go through our little roller block. I think the plans call out for 135 millimeter M5 bolt. Those were not easily accessible to me, but the all thread was. So I'll just make my own. I got a whole pack, 100 of the M5 nylocks. I'll put those on there and we'll be good to go. So that pretty much sums up our hardware, our frame. The frame I did purchase, I said this in another video, I purchased it from a local steel yard. It was $220 for everything, and that included the cuts. The only thing was they would not cut anything shorter than 12 inches, which is a foot here in the United States. So I'm having to make my own roller blocks. Not a huge issue. I had plenty of scrap left over from my frame cuts. So I will cut these. I think there's one that's two that are 70 millimeters and one is 140 or 135 millimeters. So I can cut those no problem on my horizontal bandsaw. These two pieces here, these face plates, these are really the only 3D printed parts that have anything to do with the motion or potential issues with the linear movement of the PrintNC. This bolt will run through this side, and this will mount here, and you'll see this whenever I get it all together, and this nut actually pushes on these plates. So that's the only point of the PrintNC that relies on 3D printed part. I think what most of the guys are doing is after they get their machine built, they're actually going back and machining these out of aluminum. I don't know that the aluminum is much stronger. I don't know that this is an issue, to be honest with you. But all of the weight, all of the forces do act on these plastic parts, but that's the only. Everywhere else, those plastic parts are just to align everything so that it's in the same axis on your rail slides and your ball screws and your motor mounts and your bearing blocks. So that pretty much wraps up. I am going to make a separate video going over my bill of materials, and I'll tell you where I bought everything, how much it was, down to the taxes and shipping. I do appreciate you watching me go along this video. You can catch me on YouTube. I did make a Facebook group. It's called MFR PrintNC Build or My PrintNC Build or something along those lines. MFR that's for the Flapp Ranch, and PrintNC, if you search those terms, I'm sure you'll come up and you'll find the Facebook group. The Discord channel has tons of information. I'll be perfectly honest with you, I'm not a fan of Discord. I think it's too sporadic and it's too hard to keep up with. But if you search through there enough, really great folks on there, great community. I just don't like having to go back and look through miles and miles of threads. And it's hard to tell kind of who's answering what in that. But the Facebook group, I think that'll be a good place for everybody to meet up and share some information too, especially if you're not a Discord fan. I'm not trying to steal anybody from the Discord channel or anything like that. I'm just trying to make a little spot that's easier for maybe some of us more aged CNC builders to find. So that'll wrap up this video. Like I said, I do appreciate everyone watching. Hopefully in the next couple of days I'll get all of my linear motion stuff built, and this will start to look like a CNC machine. So that'll wrap us up for today. If you have any questions, please drop them down in the comment block. I am pretty active on YouTube, and I do try to answer all of the questions because I know this is kind of a newish build. It's only been, I think Mark posted it about a year ago. So a lot of people are still trying to sort out and figure out and head scratch on this. If I can help you out, please ask. So appreciate it. There you go. Have a good one.